Welcome once again to our Engineering for the New Reality podcast series. With so much of hype around artificial intelligence, there are tons of platforms and solutions in the market, all promising to revolutionize the way companies do business. Today, we're going to look at a very specific subsegment, industrial AI. We're going to talk about the things that go into making a platform truly industrial and how the LTTS AiKno and Avital platforms, when combined, are ideally suited for industrial use cases. To give us some deeper insight into these things, I have with me our Chief Technology Officer, Ashish Khushu. Hi Ashish, welcome back to the podcast. How's it going?
Hi Akshay, thank you for having me here.
Ashish, you've always called AiKno an industrial AI tool. So what is it about AiKno that makes it so uniquely industrial?
So actually, as you're aware, we are a product engineering services company, and a large number of customers are in the manufacturing segment, in what we call the industrial space. And we wanted to see how do we leverage AI to solve the use cases which were very particular to this segment. And that's why the terminology of industrial AI platform, that's AiKno. What makes AiKno very special is that the way we have built the platform and the way we are looking at how to solve engineering use cases, that sort of distinctly defines the features that we've built in. In fact, let me just illustrate a case in point. When you're looking at digitizing an engineering drawing, an engineering drawing could be 30, 40, 50, 60, 70 years old. And when you're looking at digitizing engineering drawing, the symbols that were used in these engineering drawings a few years back were very different. If you go back and see the type of electrical symbols or Greek symbols or math symbols that were used in drawings 30, 40, 50 years back, that's very different than the way very different than the way the same symbols were used about 20, 30 years back. So it led us to a situation where we realized that when we are trying to read out these symbols, there was no OCR worth its name available in the market which could scan and identify what these Greek symbols meant, what these unique engineering drawing symbols meant. What was the significance or the meaning of the electrical symbols which were appearing in these drawings. So we went on to develop our own OCR, which we call the LTTS AiKno OCR, which today has the unique ability to identify around 200 plus engineering symbols, not only covering the engineering symbols that are used today, but taking into account the type of symbols that were used in drawings when they were drawn about 60, 70 years old back. So these are the type of unique issues or unique problems that we came across in the industrial space. And this led to us building features and functionalities which are very unique to AiKno. And so that's why we believe that what we have in hand is fairly unique and fairly focused.
So Ashish, give us a little overview on Avital. You call it an integrated smart engineering platform. What was going on in your mind when building Avital, and what are the unique challenges that it solves?
So I'll take a step back. If you look at what's happening in an average plant or a manufacturing organization, broadly, there are four areas where data is getting generated. It's on the manufacturing side. It's on the engineering side, which is the data about the product when you're creating it, when you're testing it, when you're looking at its performance, benchmarking it, looking at its quality, etc., etc. And the third part was the enterprise side, where you were taking whatever was the product that you were manufacturing and you were connecting it with that part of the infrastructure which was taking care of the supply side, warehousing, logistics, transportation, etc., etc. So till a few years back, one could say that there were three areas where analytics was being done. One was manufacturing analytics, the other was engineering analytics, which was around the product. The third was enterprise business analytics, which was addressing the business side of the value chain. In the last few years, what has happened is that there is another set of analytics which is happening around data that connected products are generating, which is the IIoT analytics. So now you have four categories. You have engineering analytics, which is about the product's performance. You have manufacturing analytics, which is about the operational efficiencies that one wants to achieve during the process of manufacturing. You have IIoT use cases or IIoT analytics, which has got to do with what happens when the product is actually deployed and you're actually monitoring the way manufacturing is happening. And then you have the business side, which is the enterprise business analytics. So these are the four areas, and we realized that look, we were very good in the engineering analytics. That's what our domain and our DNA is all about: how to understand the functionalities, the material composition, the material quality, the design, whether the product is performing well under extreme weather conditions or environmental conditions, etc., etc. So we knew it very well. What we didn't know and what we realize is going to be a very big problem is that what happens when the product is actually working? How do you find out the state of the health of a machine or a compressor or a grinder or anything which has got a rotary part in it? How do you find out how is it behaving while it's in operation, and what happens if it fails? Because of our exposure to manufacturing plants, we realized that this is one area where there would definitely be a technology intervention which would make a lot of sense, and that's what gave birth to Avertle. Avertle is our second gen predictive maintenance product. The first version was condition-based monitoring, which is, I mean, everybody calls it a condition-based monitoring. Our variant of condition-based monitoring, where we were monitoring what was the behavior of the particular asset or a machine at a certain moment in time. Now, when we come to predictive, which is naturally the next level of management of the performance, is what's the product doing and what are the early signs that one is catching to predict what is going to happen to the product, when is it going to fail, or what is the remaining life left. So that's what Avertle is all about. And it's been fairly successful in its deployments with more than about 200 of these deployed across the globe in various manufacturing organizations. And that's what Avertle does.
So, building on the conditioning and predictive monitoring that you just spoke about, could you talk a little bit about the LTTS Predictive Analytics Modeling Library? How can companies derive value from it?
That's a very interesting question, Akshay, because let's divide the equipment that we have today in two parts. One is the legacy ones where, let's say, for example, you have a compressor and it's lying on the floor or in different geos wherever the manufacturing plants are. And more than often than not, the specifications of those compressors, because they're fairly old, could be very different from one plant to the other or one line to the other. Going forward, in the next gen of compressors or next generation of HT panels or droops or induction motors, for sure, they will be designed with a criteria in mind that they would get connected on the net, and therefore they would have a mechanism by means of which the working of the induction motor would get transmitted, would get captured and get transmitted through the network to a server. Now, the situation for all the legacy equipment is that this equipment is lying on the floors, and you would like to utilize the new ways of capturing information and figuring out how do you predict when this is going to fail, and if it's going to fail, what can you do proactively to ensure that there's no downtime. So what we've done is we've gone around studying at least 36 different type of assets which are available on the design floor or on the manufacturing floor, from diesel generator, chillers, vacuum pumps, cooling towers, blowers, compressors, induction motors, turbines, etc., etc. So there are about 36 of them. And based on the knowledge that we have gone ahead and uh, done what one may want to call as a digital twinning of some of these assets. And therefore, we've been able to build a digital twin of around 50 such assets commonly deployed. And this forms the model library that we have. Now, these are physics-based models that we have created, which sort of cover the complete component functioning and the way they would work in correlation to the different parts of what a compressor would look like. We have simulated some data into these models and created a slightly more robust model to check whether it works or not, and then it is ready to deploy on the gateway that we have. Now the issue is that this is as good as we talked the last time, is as good as the modeling capabilities that we have, as well as the live data that we have. Now, the modeling capability that we have from the specs or the specifications and the physics of these equipment allows us to build an ML model which could be 60 to 70% accurate in its behavior. But we have to actually deploy it in the manufacturing plant, and then after we sensorize the induction motor, let's say induction motor, after we sensorize it with the right type of sensors, put the edge gateway, put the ML model on top of this edge gateway, take live data for a period of 15 days or a month or max 2 months to build a far more robust model, which then goes on to give you accuracies as high as 93 to 95%. What's important and what is unique from LTTS perspective is not only that we have these ML models which are built with us to the tune around, as I said, 36 to 50, some in that range. But more important than that is that we have the ability to understand what is the type of sensorization a particular equipment would require. I mean, let's take an induction motor or a conveyor belt motor. How does it function, and what is the type of sensors that are required to capture the right type of information to predict what will happen, and therefore enrich the ML model and have good amount of predictability on the behavior. Now the sensorization is as important as anything else, because if you have garbage in, garbage out, if you don't have the right type of sensors in an industrial environment, or you're not capturing the right type of data, because not only do you have to take data from these sensors, you also have to take the data from the SCADA sources that are available, merge both of these, and then come out with a model. So in my view, not only is the uniqueness of a solution coming from the fact that we've been able to build these models, but also from the fact that we have a very, very extensive, credible story around how to sensorize these equipments and how to take data and then enrich the ML model that we have.
So, Ashish, you were mentioning that Avital has over 200 successful deployments across the globe. Are there some exciting use cases we've solved that you could perhaps talk about?
Yeah, since the people listening to this podcast would be people from our fraternity, so they would know all type of use cases which go in the engineering space. So I'm fairly certain they won't find any one of them very interesting. But I must tell you a very interesting one, which was a little bit different from nature of the work that it does and its area of deployment, and that's the conveyor belts at airports. While interacting with a customer, he told us that there are airports globally where the length of conveyor belt runs in 40 to 50 kilometers. This in itself was a fairly interesting piece of nugget, whereas I'm concerned. But 40 to 50 kilometers of a conveyor belt, the entire 50 kilometers is broken down into lengths of about 4 to 5 feet. So now you can do a multiplication of how many sections and subsections that 40, 50 kilometer of conveyor belt gets broken down into. Now, when you're doing this in the baggage transportation area in the airport, Obviously, this 50 kilometer would be spread over a very vast area of the airport, and not everywhere would there be a situation where people are standing and looking at what's happening and what's not happening. And so, if one subsegment fails, obviously it will have an impact on the whole chain. And what does it do basically? You put a luggage on top of it, it checks the weight of the luggage, and it has to throw the luggage to the next segment, which is in front. And it does so by moving the bars, and the bars move because of the electrical drive. And the more the weight, the more is the power required to move the luggage to the next subsegment. The more the power is required, the more the strain on the electric drive and the motor. So now the weight of the luggage determines the current that would be drawn to drive the motor to generate a force which will take your bag, which is fairly heavy, to the next subsegment. Now imagine it fails in that part of the airport where it may take you 5 minutes to reach. What happens? Fairly a confusing and a chaotic situation, I would guess. So by leveraging Avertle, we were able to very successfully, about 98%, with 98% accuracy, predict which drive and motor is going to develop a problem. And that was a very important insight for the people supplying those conveyor belts, because that suddenly led to a far better or a lot of increase in the efficiencies and reduction in the breakdown of these belts. So I think that was a very interesting use case. We've been traveling for such a long time. We never ever imagined that this is what is the real problem under the surface of the airport.
That's very interesting. I had no idea that the baggage belts in airports were 35 to 40 kilometers long. So, Ashish, moving on, what is AiKno and Avital's roadmap? What are some of the exciting capabilities and features that you see coming up in the next 6 to 12 months?
So actually, let me start with Avertle first. Very clearly, Avertle will have a few variants. Very clearly, Avertle is having a cloud deployment architecture, and it'll be certified by all the major cloud vendors. Very clearly, Avertle will have a very rich library of models, and we aim to go beyond 100 in a very short period of time. And very clearly, Avertle will move soon to a architecture where it will be a completely a software on demand type of a model, where you could have a plant, or you could have a customer who would have its own edge gateway. He is sensorized, and all he wants is a particular model, and we should be in a situation to just ask him to download the model based on the money he gives us. So I think we're very clear on the type of features and functionalities Avertle will have. We're also clear that Avertle will soon move to a situation where it would be software or ML models on demand. So that's how we look at Avertle shaping up in the next 12 months or so. Whereas AiKno is concerned, we are focusing on various use cases for engineering, as I said. AiKno also has become an integrated part of our platforms. So when we look at IBAMs, or we look at Ubiquitous, or we look at log analysis software that we have, Novis, or we look at compute vision, we are moving to a stage that components of AiKno are being taken and getting integrated into these platforms. So this also, so that all these platforms are AI enabled from the way they handle their data. So these are the two important steps that we have planned out for AiKno and Avertle, and we are on a fairly good roadmap to execute on this.
So, Ashish, you spoke a lot about Avital delivering 95 to 98% accuracy in the predictive programs that we run today. So, do you see this going up to maybe 99 or 99.99%?
It'll be immodest on my part, and probably not very correct on my part to say yes. That is not what I perceive it to be. Remember, its accuracy percentage depends not only on the robustness of our algorithms, but also on the type of data that is fed into these models. So both of them are important, and the maturity of our algorithms is also very, very important. And as we deploy more, become more experienced, we are understanding and managing the type of challenges practical deployments are throwing up. So I would say that it'll take some time for us to be near 99 to 100%, but fairly confident about 98%.
Thanks, Ashish, for giving us that fascinating overview on the AiKno and Avital platforms. If you want to know more about these platforms, do visit our website at www.ltts.com for more information. Thank you and have a great day.